Welcome to another session of Ebenezer Gate coaching classes. Now we will do this problem, which is an analog circuit problem, which appeared in Gate 2003. A transistor amplifier circuit is shown in figure. The quiescent collector current rounded off to first decimal is. Now we'll have to find out the quiescent current. Now, quiescent means we have to find out the DC current. Okay, this is a AC amplifier. So this capacitor will not allow DC to go enter it. So as far as this is concerned, we need not consider the input here, because in DC input is AC, and therefore there won't be any DC component here. So we will just, this current is IB. This current is IB. This current is IC. Now this current comes from here. So this is also IB. And this is coming from in this direction. This is also IB. So this current is going to be IB plus IC. So you have 24 volt applied here. Then you take a loop. That loop will come here. Then go through this 560K. Then come through this drop and complete the loop. Okay, so that means this 24 volt is applied, and there is a drop in this 4.7K. Drop is IB plus IC into 4.7 kilo ohm. Plus this drop is 560K into IB. Plus this voltage is 0.7 volt. So it is 24 equal to IB plus IC into 4.7K plus IB into 560K plus 0.7. Is this clear?
Yes, sir.
Okay, and one more thing is IC and IB, how they are related. IC is beta times
B.Tech.
IB. So beta is 100. So IC is 100 times IB. So IC plus IB will be 101 times IB. So IC plus IB will be 101 times IB. So so 24 equal to 101 IB into 4.7K into 4.7K plus IB into 560K plus 0.7. So take this 0.7 this side, you will get 23.3 equal to, what is 101 into 4.7? Can you tell me? This part.
Sir, 101 into 4.7, sir.
Yes, this part.
Sir, 1
Okay. I'm just redrawing it.
Sir, 474.7, sir.
474.7 and add 560.
Sir, 1034.7, sir.
Okay. So it is 1000. Okay. Now I have just taken this part only. One minute. Now this can be solved very easily because it's a very simple circuit. There is a lot of symmetry here. So whatever voltage, suppose I would apply voltage V here. Okay, now tell me.
Sir, 1034.7, sir.
A, IB. Okay, so IB is you divide 23.3 by 1034.7.
Sir, we did not add 0.7, sir, in that.
No, 24 minus 0.7 I did, not 23.3.
Yes, sir. Okay, sir.
How much is this? 23.3 by 1034.7.
Sir, 0.0225, sir. 0.0225.
K is there, so it is milliamp. Okay. So we are asked to find out what is IC. IC is 100 times IB. So it is 2.25 milliamp. Okay, so we'll see the option. 2.6 milliamp, 2.3 milliamp, 2.1 milliamp, 2 milliamp. So what is the answer?
Sir, 2.6.
2.25, no?
Sir, but
2.25 means next
yes, sir. 2.2518, sir.
so it is 2.13. 2.25 is 2.3. Okay.
Yes. Yes, sir.
Okay, we'll do the next part. In the circuit shown below, the silicon NPN transistor Q has a very high value of beta. The required value of R2 in kilo ohm to produce 1 milliamp. So IC is taken as 1 milliamp. Now let us assume IC as 1 milliamp. This is 1. And they are saying beta is very high. Okay. If beta is very high, is very high, very much greater than 1. So IB is actually IC by beta. And since beta is very high, IB can be neglected. We can is almost equal to 0. Okay. Now we are asked to find out what should be R2. What should be R2 so that in this circuit we have to find what is R2. Okay. Now IC is, this is 1 milliamp. What is this? This current is IE. This current is IE. Normally IE is equal to IB plus IC. IE is IB plus IC. IB is neglected, so IE is almost equal to IC. So IE is also equal to 1 milliamp. So this drop is going to be IE into RE is going to be this drop. RE is 500 ohm. So this drop is going to be 500 into IE. So 500 into 1 milliamp, that is 0.5 volt. The drop here is going to be 0.5 volt. Drop here is going to be 0.5 volt. And this drop is actually, you can assume it as 0.7. This drop is assumed as 0.7. VBE is always 0.7. So this voltage is 0.7 volt plus 0.5. So this voltage is 1.2 volt. This voltage is 1.2 volt. Now we'll have to find out R2 such that this voltage is 1.2. The voltage applied here is 3 volt. So this 3 is divided into by 3 into, so the voltage VR2 will be 3 into R2 by R1 plus R2 is equal to 1.2. R1 is 60. So 3 into R2 by 60K plus R2 is equal to 1.2. So 3R2 is equal to 1.2 into 60K plus 1.2 R2. So 3 minus 1.2 is 1.8 R2 is equal to 1.2 into 60 is 72K. So R2 is 72K divided by 1.8. So what is 72 by 1.8? 1.8 into 2 is 3.6. So it is 40. 40K.
Yes, sir, 40K.
So the answer is 40. Did you understand?
Yes, sir.
I'll explain. This IC is 1 milliamp we are given. We have to find out R2 so that IC is 1 milliamp. So IC is 1 milliamp. They are telling beta is very high, so we can neglect IB. IE is IB plus IC. Since we are neglecting IB, IE is equal to IC is 1 milliamp. And the voltage, this is 1 milliamp. So the drop across RE is IE into 500. 1 milliamp into 500 is 500 into 10 power minus 3, which is 0.5 volt. 0.5 volt and the VB is 0.7. So 0.7 volt plus 0.5 volt is the voltage across R2. So that is 3 into R2 by R1 plus R2 is 1.2 volt. We know R1 and we solve it and we get R2 as 40 kilo. Okay. For the circuit for the given circuit, beta is very high. It is given that VB is 0.7. Calculate the value of VCE. Okay. Again, similar problem. beta is very high, so neglect IB. VB is 0.7. This is 0.7. This is 0.7. Beta is very high. VB is 0.7. And this is 12 volt. If this is 12 volt, then this voltage is voltage across R2. This is R2. Voltage across R2 will be 12 into 2 kilo ohm. Well, VCC into R2 by R1 plus R2 by 2 kilo ohm plus 8 kilo ohm is VR2. So this is 24 divided by 10. This is 2.4 volt. 2.4 volt is the voltage here. This voltage is 2.4. This voltage is 2.4. This drop is 0.7. So the remaining voltage will be here. What will be the remaining voltage? 2.4 minus 0.7 is how much? 1.7 volt. 1.7 volt is this drop. So once you know the drop is 1.7, that IE into RE, IE RE is 1.7 volt. What is IE? We don't know. We know RE. IE into 200 is equal to 1.7. So IE is 1.7 by 200, which is how much?
0.0085, sir.
In terms of milliamps, you could divide by 1.7 by 0.2. That is into 5. Into 5 means 8.5.
Yes, sir.
8.5 milliamp. 8.5 milliamp is IE. And since IB is neglected, IE is actually IB plus IC. So it is almost equal to IC. So IC is also 8.5 milliamp. IC is also 8.5 milliamp. IC is 8.5 milliamp. So now we'll have to find VCE. VCE. How will you find VCE? VCE is actually this voltage. This voltage is VCE. So
VC minus VE, sir.
what? VC minus VE. Okay.
Sir.
Okay. Now, if you write this equation here, 12 equal to the drop across this 1 kilo ohm. This current is IC. IC into 1 kilo ohm plus VCE plus IE into 200. Okay. We know IC and IE. What is IC? IC is 8.5. IE is also 8.5. So 8.5 milliamp into 1 kilo ohm is 8.5 volt. This 8.5 milliamp into 200. Already you know that it's 1.7. So this is 8.5. This is 1.7. If you add 8.5 and 1.7, you will get how much? So 12 equal to 8.5 plus 1.7. That is 8.5
10.3
plus VCE plus 1.7. 8.5 plus 1 is 9. 10.2. Okay.
10.
So VCE is equal to 12 minus 10.2, which is 1.8 volt. So the option is B. Correct?
Sir, I have one doubt, sir.
Tell me.
Sir, we find IC value, so multiplying with RC, we can find VC value. So
No,
we
it is
can
not VC. It is not VC. VCC 12 minus IC into 1K only is VC.
Sir, can you tell again, sir?
This here what is the voltage?
12, sir.
12. You want to find this voltage, right?
Yes, sir.
12 minus this drop is only this voltage.
Yes, sir.
12 minus IC into 1K is only this voltage.
Okay, sir.
Okay.
Yes, sir.
Okay. If the transistor in figure has high value of beta and VB is 0.65, the current I flowing through the 2K ohm resistance will be. Okay. Now VB is 0.65. So this voltage is 0.65. This voltage is also 0.65. Okay. You have to find this current. Now, this voltage is 10, high value of beta, so you can neglect beta, neglect IB both ways. So what will be this voltage? This 10, 1.85 plus 1.65 is how much? 1.9, 2.5, 3.5. 3.5 plus 6.5 is 10. So it is easy. So the current going here, the current going through this will be 10 divided by, you are neglecting IB. This is neglected, this is neglected. It is as good as this. There is no connection to the transistor. So 10 divided by total resistance is 6.5 plus 1.85 plus 1.65. 10 divided by 10K. So this current is 10 divided by 10K or 1 divided by 1K, which is 1 milliamp. Understood? This current is 1 milliamp. So this voltage is 1 milliamp into 1.65. This voltage is 1.65 volt. This voltage is 1.85 across this resistance. So this is 1.65 plus 1.85. This voltage is 3 volt. Voltage here will be 3. Here it will be 3. Then this drop is 7. Sorry, this voltage is 3.5. Sorry. And this drop is 6.5. Now we'll have to find out the current. Okay. Now, this is 0.65. This voltage is 1.65. If this voltage is 1.65, this drop is 0.65. So this voltage will be what? 1 volt. This is 1.65, drop is 1.65. So this voltage will be 1 volt. This will be 1 volt. Okay. If this is 1 volt, the current through this will be 1 divided by 1 kilo ohm, which is 1 milliamp. This current will be 1 milliamp. This current will be this IE and this is IC. IC is going to be same as IE because IB is neglected. So this is also 1 milliamp. This is also 1 milliamp. Again here, if this is IE of this current transistor, this 1 milliamp means this current is also 1 milliamp. So this current I is effectively 1 milliamp. Okay. Understood? Clear?
Sir,
Yes, sir.
in each resistance we use voltage divider, sir.
Yes, yes. In the base, since base current is not there, it is as good as these three are not connected.
Yes.
So 10 divided by this total resistance is 10 kilo. So it is 1 milliamp. 1 milliamp into 1.65 is 1.65 volt. Here 1.85 volt. Here 6.5 volt. This is 1.65 volts. Drop here is 0.65. Reduce 1.65, you will get 1 volt here. Your this is IERE. IERE is equal to 1 volt. So RE is known, so current IE is equal to 1 milliamp. This current IE is almost, this current is same as IC, so here also it is 1 milliamp. This IC is the IE of this transistor, which is equivalent to this IC. So the total, this current is 1 milliamp. Okay?
Yes, sir.
Consider the circuit shown in the figure. Assume that base to emitter voltage VB is 0.8. Common base current gain alpha is of the transistor is unity. Okay. So the value of the collector to emitter current VC. What is all? So we know IC is equal to beta IB, and we also know IC is alpha IE. Okay, alpha is generally beta by beta plus 1. So here we are saying alpha is 1. So alpha is unity. So IC is equal to IE. Now they are asking us to find what is the value of VC. So to find the value of VC, you just have to find what is this current. To find this current, you will have to find what is this voltage. What is this voltage? This voltage is 16 divided by 16 plus 44
into 18, sir.
Into 18. How much is it? 16 plus 44 is 60. 18 by 60 is 18 by 6 is 3. 18 by 60 is 0.3. 0.3 into 160 is 4.8. 4.8 volts is this voltage. This voltage is 4.8 volt. This 4.8, VBE is given as 0.8. So this drop is 4.8. So this voltage is here is how much? Tell me. How much is this? This voltage?
So 4.8 minus 0.7.
How much is it? 4 volt.
4.1, sir.
0.8. VB is 0.8, given as 0.8.
Yes, sir. Yes.
So 4.8 minus 0.8 is 4 volt. So what is the IE? 4 divided by 2K. That is 2 milliamp.
Yes, sir.
Okay.
Yes, sir.
IE is 2 milliamp. IE is same as IC because alpha is 1. So this is also 2 milliamp. So drop across the 4 kilo ohm is 4K into 2 milliamp, that is 8 volt. This drop is 8 volt. This is 8 volt. This drop is 4 volt. So total drop is 8 plus 4, 12 volt. Applied voltage is 18. So the VC is how much? Tell me. This drop is 8. This drop is 4. Remaining is VC. What is applied 8?
Yes.
18. So how much is
Sir,
it?
2, sir.
Huh?
2.
This drop is 8 volt. This drop is 4 volt. So 8 plus 4 how much?
Yes, sir. 12, sir.
12. Applied voltage 18. Remaining will be VC. How much?
Yes, sir. 6.
6 volt. 6 volt. 6 is the answer. Okay. Okay. We have completed. So we have done 5 problems. So try to revise this. It's very simple. This quiescent voltage and quiescent current, it's very easy to do these problems. Thank you. God bless you.
Thank you, sir.